All right, as per usual, all credit goes to these people over here. Let me grab the notebook and start discussing about other stuff, especially since we do need to continue here and end it pretty much soon. What I mean by that is that I don't know what I'm talking about anymore. So first of all credit goes to these people, as I said multiple times. There are certain things I want to discuss because, as you know, things about subsonic and supersonic, they're always opposing each other. But I'm just realizing that if if what hypersonic is basically is going over to the M infinity route, right? If that's true, then all these isotopes are actually very important, right? Because those isotopes tells me what the end thing is. So that would mean basically that there's a harder limit in these supersonic things that are not universally thought of, right? What I mean by what I'm trying to say is basically I never thought of it, and now I'm just thinking about it. And yeah, there's an isotopic limit on some of these equations that are hypersonic that I never really thought about until now. Yes, I have been taught this a long time ago by different professors, different things, but I never thought there was a limit to the equations, like when you go to hyper, which is interesting. Never really considered there's what I'm trying to say is that there's some when you talk about frictionless heat addition removal, there's a graph, right? That you look at. And there's a few graphic isotopes in it, like the pressures and everything. And I always wondered, why am I thinking about this, first of all? Well, I was thinking of hypersonics, and hypersonic just means a large Mach number going to a large number, right? Well, if that is true, then Fm over here, this equation, well, I'm not sure if this is true, but if my assumption is correct, then when we have this kind of like graph, this limit, we can maybe do a Taylor series expansion at affinity, but we know what the end result has to be. Interesting. I'm gonna have to look at that more. Think about if I said it's not true or true, because yes, there's some. Yeah, I'm gonna have to think about that. Unfortunately, I have no idea right now. Unfortunately, I have no idea, but I have a guess on some of these things. Maybe someone can inform me about it, but I have a guess on some of these hypersonic equations because think about it. What the hypersonic really mean in reality? If I ever get to some of these equations now, because I'm thinking about this and I'm thinking about this like pressure, right? Pressure over P, which is I believe it was D and then U, right? And then we have something like Mach M, something like that. You would have to just get the highest order term. And that might be the reason why that a lot of the times in these notes, there's some higher order term that you keep on looking at. And if my idea is somewhat universal, then other people have thought of this before. And I think they have. So let's just start with the ice. I mean, I don't know really. This is just a thought I had. And the reason why maybe some of these Taylor series at infinity is an idea, maybe. I don't know. Well, that's just a thought I had. For example, if I were given the Hazen or the what would they call it, the Hessian equation again? Like I forgot what they're called. The stagnation properties and then what was it again? Oof, these notes I need to the shock jumps. You would just delete some of them because you're going to strong jumps, and they already do it over here, as you can see over here. And I'm thinking the reason they're doing it is for hypersonics, basically. Because I was thinking a little bit. That's the only reason I can think of. So if I can ever get those equations from here, which I don't know where I put them, I have put them somewhere here, and I promise you that. But I'm thinking that hypersonics is due to the large Mach number, which once I find, I will, but that would mean the governing equation is basically this: 2 gamma, gamma plus 1, mu squared, td over tu, tdn squared equal gamma minus 1 divided by 2 gamma, 2 gamma, gamma minus 1 divided by gamma plus 1 squared m squared, and then gamma plus 1, gamma is supposed for ud. That's gamma plus 1, and the gamma minus 1. I know that the graph is shit because I'm not sure if it's correct, but in reality, that should be it. Because think about what I'm saying here. What you're trying to do is just make Taylor series large, and we know what the higher order term is basically over here. You see all this, and that should be it. Well, this is more of a thought experiment because I don't really know if it's true, and none of these notes actually show if they're true yet, which I hopefully do soon. Maybe I can ask the previous person that took this that actually got into hypersonics. There'll be a lot of soul searching. But yeah, that's the idea I had. I think that would make sense, doesn't it? And all these isotopes make sense why people would be interested in it. Just a thought. Well, well, this is a short video just discussed what I thought about hypersonics, but we will catch back onto the regular topics of frictionless and friction. And I have an idea for the frictionless that I never told anyone. Friction, when there's friction in it, because I read that section. I was wondering if I can make a rotation. Like I don't know how to say it, but there's an idea I had in my head that sounds insane, but it might be something. Because there's a whole entire equation sheet over here about rotational with the friction, one dimension AD with friction, yes. But I always wondered this question, which I'll ask once once I have a good picture of this. But what if there was something doing some kind of rotation mark like this early over here or something, making this move panel like this or something, some kind of track pad over here, some kind of middle track pad that makes it move. And the friction actually helps the movement. Then over here with the friction over here, it wouldn't be a minus 4 tau wall, it would be a plus 4 tau wall, and it would be a plus over here instead, and everything would change over here. Because I was thinking about something, and maybe I don't know if anyone could test it, but what would happen if friction was moving like this? The wall was moving like this with the flow, which means that basically it was helping the flow go through. Now, it's an interesting idea I had. I don't know how mathematically it would be. It's just another thought experiment, basically. No idea how I would actually mathematically solve that yet, which is why I'm looking at this and was looking at it for some time. I don't really know from this one section. I think there might be pages I'm missing then, maybe. But that's the idea I had, and I was thinking, what if we were able to like, if the chamber was rotating this way and this was rotating that way? What would that change the geographic of the combustion outwards? Because yeah, you can make a tau wall, yes, but what if that tau wall was moving? It's a curious idea I had, although I'll never have an answer to it. I'm sure the only thing that would happen is like a negative sign change to a positive, and that's it. I'm pretty sure that's it. And but I hope there's something interesting there. I will see that later. Actually, I'll try that out. Although I'm sure it'll be useless because why on earth would it be useful? Because you're thinking like this, like just like this. You're gonna have to build some kind of tracking like this. That'll be weird. And there's no guarantee that thing will survive the combustion and the heat and the wear and tear. Yeah, this video is more of a thought I had. Um, I will definitely ask this question later on in my life. But I'm pretty sure it's just going to be a sign change. All over here is just going to be this addition is going to be